Welcome to this Harper College podcast. For more information on Harper College programs, classes, and events, visit harpercollege.edu.
What exactly is nanotechnology?
Nanotechnology is looking at the world at a level sort of from the size of atoms up to kind of wavelength of light. So a nanometer is a billionth of a meter. So it's looking at the world from the size of, say, an atom, which is like tenths of a nanometer, to tens or hundreds of nanometers. And those are objects which are smaller than you can see with an optical microscope.
Okay.
Optical microscopes you can see down to like 200 to 300 nanometers. Nanotechnology, materials, electronics, and there's a lot of interest in kind of biotechnology at that scale.
Why did Harper decide to start the nanotechnology program?
And it goes back to before the current meltdown. There's projections that it was sort of one of the next new waves of technology that would need workers at all levels of education, ranging from technician up to PhDs. And then the market was projected to be like trillions of dollars in 10 years, zillions of workers. Those are certainly probably optimistic, but it's clearly making it. The products are clearly beginning to make their way into our everyday lives. So it's not just a research project.
How is the Harper program going to differ from the program at maybe like a four-year school or university?
Almost all the four-year programs are really aimed at getting people into graduate school. They're aimed at more of an academic career. That's changing too, and we are developing transfer agreements with four-year schools. We're aimed at two things: one, allowing people to go to four-year school, and then allowing people to get jobs as kind of at the technician level.
How many universities in the area around Harper and the Chicagoland area that offer four-year degrees in nanotechnology?
Almost nobody offers a nanotechnology degree. It would be a degree like material science, different kinds of engineering. You can look at nanoscience as like one new slice of a lot of different fields. Probably a better way to look at it.
How many courses are specifically for this degree to get here?
There's 8. Well, really 6 specific courses. Where there's then 2 which are not really. I mean, they're courses. You get credit, but they're not traditional courses.
How well is the field doing right now, and what are the prospects for the next 5 and
Well, if the whole economy doesn't fall apart, it's a lot of this effort goes into the pharmaceutical or medical, like diagnostics, things like that. That tends to be, nothing's perfectly recession-proof. That tends to do okay. There's a lot of things with related to energy and environmental concerns to touch on nanoscale materials. So that, if I had a crystal ball, wouldn't be sitting here talking to him. But that stuff looks like it's going to get supported fairly well.
When did this field start? The nanotechnology field start to really develop?
There's 2 answers. There's a political answer, which is that when the Clinton administration started the NNI, which I think stands for National Nanotechnology Initiative. You can check that. But it in the sense that was the first concerted effort to bring about to coalesce, bring together a lot of disparate efforts under one umbrella. So that's the political answer. So then, to be frank, that was kind of their attempt to leave their legacy on the scientific community. from more of a technology and science point of view, in 1980s and 90s, there was two kind of things which actually led to Nobel Prizes. One was the discovery of these strange carbon structures called buckyballs and carbon nanotubes. So these strange structures of carbon that existed all along in nature, but we never knew about them. Mm-hmm. And they have some unique electrical and physical properties, like right now they're in some tennis rackets because they're making the tennis rackets strong. You can use them as drug delivery systems. A lot of ways you can use these structures. So that was kind of on the material chemistry side. That was, I think, in the 80s, 90s. The other thing that was the invention of a device called an atomic force microscope or scanning tunneling microscope. It was basically a tabletop device that lets you see individual atoms. And that was in the 1980s. So those two kind of scientific developments really sparked the field.
Are there different areas that I would be able to make a study in the nanotechnology field?
In the future, it may make sense to split off into things like biotechnology uses a lot of nanotechnology stuff, if you will. So in the future, it may make sense to kind of differentiate. But right now, it's just one program.
Will I be receiving any real-world experience with this?
There is as part of the program, there's an internship that's available. We also have agreements with some universities where you can actually do what's called a Capstone experience. You can go and spend a semester at someplace like the University of Minnesota, where you get a kind of hands-on experience with world class, whatever, leading research instrumentation. So that's really a way for students to get to work with kind of leaders in the field.
Okay.
In a real kind of hands-on, intense way.
If I currently worked in maybe the health science or manufacturing field, how would this program help me?
A lot of the instrumentation we use is or will become kind of more widespread in those fields in the next few years. Few is anywhere 1 to 10. Mm-hmm. Example I always like to use is the hair care industry. We use some of these instruments to look at how hair conditioner sticks to hair follicles. It's just mundane stuff like that, or how fingernail polish sticks to the interface. A lot of times, the interface between materials is a kind of nanoscale. So whether you're looking at the interface, I've seen pictures of the interface between the glaze on the tile and the substrate. Mm-hmm. They look at how that adheres. A lot of times they'll use instruments like this to look at that, or fingernail polish seems to be a favorite. There's one product that measures basically at an atomic scale how slippery things are. So what they want to know is how they're looking at the buildup of hair care products on hair follicles. So it turns out, I think, if conditioner builds up on your hair, it makes it more slippery than the hair itself. So they actually use these nanoscale instruments to look at kind of the buildup of conditioner.
What kind of experience have you had with this? What did you do?
I really came out of looking at the world of kind of wireless sensors. The idea there is traditionally sensors may have cost hundreds of dollars, so you can only afford it. So if you're trying to monitor a bridge or a building or whatever, you can only afford to monitor a few points. If you can inexpensively produce sensors using nanoscale techniques, you can make them so they're essentially pennies, so you can create kind of a fine grid view of the world with these sensors. Trying to give you some examples. People have looked at the bridge that collapsed in Minneapolis. Yeah. And the question people are asking, bridge sensors today are not that expensive, but they're big, chunky stress gauges, like this size. Get the string wire to them and all that. And so if you can, instead of using 10 of those or 50 of those, if you can put, monitor every joint in the bridge, you can And I think it's pretty well accepted. If you can do that, you can get a much better idea of kind of the condition of that bridge. You can also measure things like, well, what happens when this kind of load passes over. So that's where my interest came from. We did things like looking at monitoring the environment for like biohazards, for radiation hazards. We didn't make the sensors, but using other people's kind of sensors, which a lot of them were made of nanoscale or kind of pre-nanoscale techniques.
Thank you for listening to this Harper College podcast. More information is available at harpercollege.edu.